Welcome to the IVUS and OCT lecture. So what we're going to do is really go through examples. So we'll start with healthy and then kind of work our way through. Now there are, of course, way more complex, especially with OCT imaging, that I'm not going to go over, but if you have a case or see something or have a question about it, just send it to me. But I don't want to overwhelm you right away. So let's just go into a few examples to be able to tell kind of the big things. So remember with the technique, we start from the inside, the innermost not necessarily being the center, but being where the catheter is. So almost in every picture, every frame, you should have a catheter and a wire. The wire artifact may or may not always be there, kind of depending on what frame you're looking at, but the catheter should always be there. So the catheter is a perfect concentric circle. So if you see this is a pretty perfect circle, you have some halos out here that we like to call that. But you definitely have a perfect concentric circle. So that is the IVUS catheter, or OCT if we're talking about OCT. So do you remember at least the normal order of vessel layers? The centermost being the Lumen, and we had a cool acronym, LIMA, Lumen, Intima, Media, Adventita. Okay, L-I-M-A, LIMA. So the centermost, we kind of look at color changes and different shading when it comes to IVUS and OCT. So you definitely have this catheter, and then immediately outside of the catheter, now over here it's a little condensed, so look over here, we have room. The next color change should be the lumen, because the catheter sits inside of the lumen. And then you can kind of see all of this is pretty much the same shade and morphology. So all of that would be the lumen. Now, do you see the next color change where it goes to a brighter white and kind of a different texture? So you should see it goes from kind of this texture you're seeing here to this one that you see here. That actually looks like tissue, because it is tissue, and it's a little brighter white. So that is the start of the intima. Okay, so if I were to kind of circle it here, all this is the intima, all this is the intima. And remember, this, you're not going to see everything in one frame all the time, which is why you kind of toggle between frames. You see it's a little blurry here, a little blurrier here, that's okay, right? But can you see that first white line? That is the intima. Now remember, LIMA, the M stands for media, and the media is darker, right? It's kind of like a sandwich. You have white, a darker black, and then white again. So that middle part, that darker black band, that is the media. And why is it darker than the intima? Because it's vascularized. So remember, blood kind of turns up darker black on IVUS, so this is the media. And then the next color change where it changes back to white, that is the Adventita. Okay, so this would be intima, this would be the media black band, and then this would be the Adventita and the lumen. So if I were to size this vessel, I would trace out the media. Okay, we measure what I call media to media, the external elastic lamina, which I'll show you more on the OCT side of things, but this is how you would measurement. And then if I was doing a quick diameter, two kind of perpendicular diameters here, you would have, remember, each white mark is 1. So this is 1, 2, 3, 4.5 that way. And then marks are down here, that's okay. This isn't quite a full 1, but neither is that. So we'll say this is 1, 2.5, another 0.5 is 3, so maybe 3.75 that way. There you go. So this is a normal healthy vessel. So what you're really looking for in a healthy vessel is that there's no real space between the vessel layers. So it literally goes intima, media, adventita. There's no space between them. That's a nice big lumen. And again, the vessel sizing wise, that depends what vessel you're in. We don't have that context here, but this is a pretty healthy vessel and we should be happy with that. Okay, they don't have any plaque or anything. So now let's go to this example. I'm going to bring that to the front real quick. Okay, and Now, don't skip steps until you're super, super comfortable and trained. Even me, I love IVUS and OCT. I still go through these steps every time, a little quicker in my head, right? I'm not like narrating to myself, but I start from the center and I work my way out just to make sure that I don't miss anything or misinterpret something. So remember, this is the catheter. Here you actually do have wire artifact. So what you're gonna see is this brighter white close to the catheter because the catheter is over the wire, right? And then you see this shadowing out here that we call wire artifact because the wire is metal, right? And it can't penetrate or kind of see through it. So you're going to have that shadowing where that wire is, which isn't a big deal. You just, if you're measuring, you know, a diameter, you don't want to pick the part that the wire's at. Pick a part where you can see the media. So this is the catheter, wire artifact. And then you have a color change, right? From those concentric circles that goes to this gray shading that's all about the same. And then can you tell when this texture changes to a different texture? I hope you can. So look at this texture and then look at this texture. Are they the same or are they different? They're different. This is kind of a little grainier and this is a little blurrier. So that means this is the lumen, and then where that new texture starts, that is what? What's the next vessel layer? The intima. And then where is the media? So I'm going to write this in there so it stays. This is the catheter, wire, lumen. Intima starts kind of here. And then where's the media? We said the media is a darker black band. So zoom out with your eyes a little bit here. Do you see a black band you can trace your fingers around? Should be about right here. Okay, so that is the media, and then where it changes to white over here, that's the adventita. So why is there this space between the intima and the media? You see where the intima starts to where the media is? Why is there this gap here? This gap here, this gap here. Let me trace out what I would call the intima in purple. All right, so what is between the purple line and the green line? Plaque. Okay, plaque builds, grows, develops between the intima and the media. That's actually an important thing to know about atherosclerosis. Okay, this is where foam cells develop. This is where kind of plaque is located in between these two layers. And that becomes important when you're looking at something like this and you go, well, what's between the intima and the media here? All of this is plaque. Okay, so when you're doing atherectomy, this is what you're trying to remove to increase that lumen area so that it is the size of the green line, the green circle, instead of the purple circle. Okay, so there's one example of kind of a fatty plaque. Now over here, if you just compare these two images, look at this and then look at this, there's two completely different kind of textures going on, which we're going to talk about. But remember, we don't skip steps. So let's go from the middle, right? This is the catheter, the IVUS catheter. I do want to be specific on that. And then the next color change, do you see kind of the black area that's about the same texture? If I kind of colored this in here, right? So what would that be? What comes right after the catheter? The lumen. This is quite a small looking lumen, but a lumen nonetheless. And then do you see where it changes from black to white? So that immediate point in which it changes to the white, that should be what? What's the first vessel layer? The intima. Okay, so this is where your intima is, right where your lumen ends. Can you see the media? I'll zoom out a little bit. The black band. Yep, so I'm going to draw out the media with this green. And in some areas, like over here, you're guessing a little bit because you can't really see a distinct black line. So remember, that's the media. And then the white, which is where I just drew my M, but immediately after that black is the start of that adventita. Okay, but remember, if this is the lumen and the intima, what's between the purple and the green line? Some kind of plaque, right? So why, if we're comparing here, I'm going to outline this plaque, or this lesion, we'll say. You see how that's a whiter texture than this one? This one was like kind of a darker gray. All right, well, white, this is a wire artifact, by the way. You see that like white deposit? And I know that's wire artifact because, what's this? Right, the artifact behind it. Actually, that's not true. I take that back. The wire artifact's over here because it comes all the way up to the catheter. So this is actually inside of this plaque, so it's probably a calcium deposit, which is why you see black shadowing behind it. That's a classic sign of calcium on IVUS. And I'll just circle that. So that's a deposit, and then this is acoustic shadowing that's inside of the plaque. This is wire artifact because it comes all the way up to the catheter. So back to my original point. The reason that these are different in color, and this is whiter, is because this is a fibrous plaque. Okay, versus this one was a fatty or a soft plaque. So the denser that a plaque is, right, once it becomes calcium, it gets that bright white and then you can't see through it. But the whiter it gets, the more fibrin is in it, the harder of a plaque that it is, which is why it is plaque. It's between the intima and the media. They're just different textures because they're different densities. Okay, so I hope that makes sense. Now let's look at the most dense, which would be calcium. But again, I'll keep saying it, we're not going to skip steps. So you see this is the catheter. The next black after it, all of this would be the lumen. Okay, so I'll outline the lumen a little bit there for you. All right, so then where it turns white, which you can see right here, that is the intima, right? Which, yes, the intima kind of lines the lumen. Now can you see a black band? In some parts, yes, you can actually really only see it here and maybe a little bit there. Let me undo that so I can make sure I am, yeah. So you can definitely see like this is a grayer and then this white here. So I know that's the intima. And then if I kind of traced out this media with my finger, you can see there's a difference in texture between here and here. So I know that this is probably plaque of some kind, the end of the media, and then, sorry. I know I'm just drawing all that in purple. That might not be helpful. Let me do it in the laser. So lumen, intima, something else going on, end of the media, start of the adventita. So if I sat here and I traced where I think this, a little more out there, where I thought this black was. That's why it's important to really understand the media, because if you measured here, you'd severely undersize that stent. But then we kind of like lose all our layers out here, right? Which is a telltale sign of calcium. Calcium on IVUS has to have two things. Number one, you see this bright white, correct? Okay, there is probably some here, but this is the wire artifact, so it blocks out that area, but it's definitely probably also there. So this is calcium, bright white, followed by acoustic shadowing, meaning I can't see anything behind it because it's so dense that the sound waves, and remember where the sound waves come from are that catheter, right? Where the transducer is, the sound waves come out and come back really quickly because it's dense, right? It bounces off really quickly and it doesn't penetrate through. So according to the transducer, it's like, actually, I don't know what's behind here because that came back so quick. I didn't really have time to go through and relay back what was there. So it's just going to turn up black. It's not that there's nothing back here. Okay, all of this is back here too. You just can't see it. So what will happen is when you do some atherectomy runs, and let's say you get rid of that calcium, then you should be able to start to see, if you redo IVUS after your runs, what is going on behind here. So then you can properly size the vessel for your stenting. Because if this was a really oval vessel, right? What if the media was all the way out here and you just assumed the media is probably right here? That would be a really undersized stent. Okay, another example. This is the catheter. This is the wire. You see it's touching the catheter, the artifact back here. This lumen, again, very small, start of the intima. You see the media all the way out here, that black band, all the stuff in between is plaque, but you do have a mixed morphology here. So you have softer plaque over here, you have a little more of a fibrous plaque here, you have some calcium deposits back here because you have that acoustic shadowing, and this is a fibrous deposit. It might not 100% be calcium because I can still see behind it. This one is an interesting one that no one really wants to see, but if you notice, it's very dark, right? Very dark image compared to the image up here. I don't want a ruler. The image up here, I can see everything. I kind of just see the catheter, the lumen, this bright white circle thing, and then like not a huge distinction out here. A little bit, but not a lot. That's because all of this is a concentric calcium. So the calcium is 360 degrees around the vessel, so I can't really see anything as far as the rest of the vessel sizing and morphology. Sorry, I keep bringing that ruler up. Okay, the last one regarding IVUS that I want to show you is what a stent looks like on IVUS. So remember when we saw the wire that was that bright white. So on IVUS, you're going to have, I'll write it up here. On IVUS, okay, what's bright white is going to be like bone. So we'll say calcium or metal. And metal can be a few things, right? Metal can be the wire and metal can be stent struts. So you're gonna have to differentiate kind of between those two things based on, can I see through it? Is it close to the catheter? Or is it up against the intima? Based on your understanding of those components. So this is the IVUS catheter. This is the lumen. Now what I want you to see is kind of similarity in texture here. Okay, lumen. Now notice, where is the white? So this is the catheter, the lumen. Is this the intima or is this the intima? Ooh, right? Good question. This is the intima because the intima is white, right? So the intima is all the way out here. I'm not 100% sure if that's a little bit of plaque or not. No, I mean, this could be the intima. And this could be the media, and this could be the adventitia. Actually, that is more likely, because this is definitely the intima here. Okay, so let me draw where I think the intima is. This is from the IVUS app for Boston, which I'm not really agreeing with where their measurements are, because you see this is a different texture than that. So I'm going to say that green circle is the intima, and then this is the media, and that brighter white is the adventitia, kind of out here. So there's some plaque here for sure. Okay, but the stent struts, I don't know what color to put these in, maybe blue. Here, here, and here. Okay, this is a wire. This is not a stent strut. There might be one back here, but that is definitely the wire. So don't think that stent strut's that close to the catheter. But the rest of these are what we call malopposed. The blue should be touching the green. So because there's space between the blue and the green, all of this is lumen back here. Okay, meaning the stent strut is just hanging out in the lumen, and this is how you get in-stent thrombosis, okay, because you have kind of clot develop here since there's blood flowing there, and then nobody wants that. Okay, so when you look at something like this, you're going to look at the stent strut. You do want to look at the size. Now, if you can get it, you know, fully expanded, it's a little bit undersized, right, because there's still residual plaque here. Really, you want it out to the purple, but we're not always looking for perfection here. But you definitely want to get a non-compliant balloon and oppose these markers and these stent struts to the green, to the intima, so that this lumen is free and clear. Now let's shift over to OCT. So first we're going to look at a normal OCT, and really you're going to use the same concepts that you use for IVUS as far as working from the inside out, right? You're going to have a catheter, you're going to have a wire, you're going to have a lumen, intima, media, adventitia, okay? But we won't go that fast. So in the center, or really the concentric circle, should be the catheter, right? In this case, the OCT catheter. And then there's a wire. Now what you notice about this wire is it's not always super close to the lens. Sometimes it's out here, but it's way more distinct. It's gonna look like what we call a comet. Okay, so you have kind of the ring of the what is this called? Arc of the comet, and then the tail. Okay, and you're gonna have that, like you can even see it in the picture down here. Then you're gonna have the lumen. So the lumen is gonna be nice and dark, right? Because in this case you use contrast, and that's why sometimes you get a little bit of this haziness here in reflection, because this is contrast. But this is the lumen. Let me get something so it stays. Catheter, wire, lumen, lumen, lumen. So now the next color change, right? Same idea that we did with IVUS. The next color change where it changes to this yellow is the start of what? The intima. Okay, then how do you know the media? So you're gonna look at color changes again, and it is still gonna be darker. So it's gonna be yellow, dark red, reddish orange, and then yellow again. And remember, that would be intima, media in the middle, and then the adventita in the outermost. So now this is a very healthy vessel. There's not a lot of space between the three layers. Okay, the lumen is nice and large, but I would say this is the media. And again, sometimes have to use my imagination out here. All right. Now, this is where we talked about kind of the external elastic membrane, okay, external elastic lamina. Now, on a microscopic scale, what you're looking at is this section is the intima, right? Well, there's more layers than that to a vessel, right? You have endothelium, you have endothelium over here, then you have the internal membrane, then you're gonna have this internal elastic membrane and external elastic membrane that kind of wall the media, all right? And the media would be in between the two. Now, this is, you know, sometimes fractions of a millimeter of difference. It depends how thick the media is. But if you had a very thick media, let's just say like all of this was the media for a second, and I was measuring a stent here, that would be a very big difference from here to here. So that's why when you're being trained in OCT, they'll say measure from the external elastic membrane, which means the outer edge of the media versus putting your markers here in the middle. So let's use like this as an example. Can you see kind of the dark band around? This is the media, okay? So the difference would be, let me measure from the internal for a second. So let's say I was like, oh, well, that's, you know, the start of the media, but where I actually want you to measure is the external elastic membrane. Okay, that would actually be out to the green for your stent sizing. So that's why it's important to understand that, just so you're measuring accurately. I know it does it automatically, but you can move the markers. You just want to make sure it's the right place, especially if you have a really thick media. It could be a millimeter of a difference, which does make a difference as far as diameter. So keep that in mind. But while we're on this example, let's label. So we start from the center, catheter, right? Wire, the wire artifact. You have the lumen, you have the intima where it starts, you have the media, and then you have the adventita, which is still the yellow out there. Now, if you just take a look here, you see 1, 2, 3 vessel layers, but here not so much, right? It's a little hazy. So what you're actually looking at is what plaque looks like on OCT. So if this is the intima and this is the media, right? You see that black band. Remember what we said, what's in between? In between the intima and the media, this is where plaque develops. So what that means is all of this, it's just heterogeneous plaque, but it's still plaque nonetheless. And then on OCT, it just looks like a very thick intima. What you're looking for in a healthy segment is like this, where the vessel layers are very close to each other. But if you're starting to see this kind of thicker looking intima, all of this yellow, that is the soft plaque. Okay, now comparison is for calcium. So we'll do the same thing here. Catheter, wire, wire artifact, lumen, lumen, intima. Okay, this is the start of the intima over here. Media, I can't really see too much, maybe out here. But what I do see, okay, besides the fact you have this like funky looking intima, right, that's plaque. But what I can see out here are what we call dark islands, okay? They have distinct edges, they're very dark, and they look like deposits, okay, in the media. And by definition, what is between the intima and the media? Plaque. What happens to very developed plaque? It becomes calcific. So this is actually what calcium looks like on OCT. So the big difference between calcium on OCT and the calcium on IVUS is you can see through it, and they have dark edges. Okay, so I do call them little red islands versus, I can pull over let's pull over this example, just do a side by side. And this is why I completely understand if you switch from IVUS to OCT and you've never really seen OCT or you've never really seen IVUS, you're used to one instead of the other. It can be difficult because they do look, you know, very different. So this is calcium on OCT, and then this is calcium on IVUS. Okay, very different. Now, the next thing I really like to look at is stent analysis on OCT because I think you can see it really well. So remember, same idea. This is the catheter wire. So this comma is very close to the catheter. Lumen, right, the big black thing. Now you see the stent struts. Okay, the bright little things inside of the lumen, and then you see they have some black out behind them. Okay, those are stent struts. I'll just keep maybe 2 of them circled for you. Now, where's the intima? The bright yellow, that's not white. And then the media. Now I can kind of see the yellow here changes to something different. So I would say maybe the media is out here, kind of where that intima ends. Now, what am I thinking about this stent? So where should the stent struts be? Up against the yellow, right? Like this one. This one's a great example. This is opposed. Unfortunately, all of the others out here are unopposed, meaning there's black space between the stent strut and the intima. They're not touching. And remember, that's that in-stent thrombosis concern. So you'd use an NC balloon to kind of oppose those stents, and you would want it to look more like this. Now, don't get confused, right? This is the wire. Don't think that's a stent strut. All of these are stent struts, and each of them are touching the intima. They are well opposed. Yay. Sizing wise, this is the intima. Media is question mark, probably out here a little bit. So maybe there's definitely some residual plaque, but at least all of these are opposed. You have a decent lumen area size. Maybe it could have benefited from some atherectomy, don't know, but that is a decent result. Now, what you can also see is the endothelialization process itself, which is kind of cool. So I would look at this and I say this is an exposed stent strut, right? It's literally the intima and the stent strut is on top of it and the lumen and blood is right here, which is what it's going to look like when you place a fresh stent. It is not endothelialized. It is not healed yet, okay? You're looking for the endothelium to kind of develop over it. So then if they come back, or you're looking at an old stent, this is what you're looking for. So you see the stent strut is actually ingrained into the intima because the endothelium grew and developed over it, and now you have a nice smooth surface and no exposed stent struts going on. So that is the goal. I hope that was helpful to go over some of the basic examples. When you're first starting, at least understand the vessel layers, the lumen. Once you get really comfortable with that, everything else will start to make sense. Because if you understand where plaque develops, right, between the intima and media, you understand where a stent is placed in the lumen, or where thrombus would develop would be in the lumen. When you start to see different things and artifacts, use that basic foundation to kind of eliminate things, because you know there wouldn't be thrombus between the intima and the media, so you can help that and kind of differential diagnose almost what you are looking at.